Okay, we start. 1 minute. Let me present my screen. Sorry, 1 minute. Okay, so since all of you are here already, then we will start our class. Okay, 1 minute. I think we stop at the chapter 2, so I think we have to rush a bit. Hopefully, today I can finish everything. Okay, where we stop? Any idea? I think this one not yet. But this one I think done already. Am I correct? Chapter 2 finish already. Confirm? So fast, man. Confirm? Eh? Seems like got coherent. This one done already. Confirm? The rest? Hello? No one know. Okay, you think done already? Okay, then I proceed to chapter 3. Let me check first. Let me check the tutorial first. I can't remember. Yeah, this one done already. Yes, done already. Yeah. Chapter 2 done already. 我不知道. Okay. Chapter 2 done already. How about the tutorial? Tutorial also done. Yeah, I think so. Yes. Okay. Then I proceed to chapter 3. Sorry, too long time already. Okay. Chapter 3 is talking about the eigenvalue and eigenvector. I think wait. I think you mentioned to me before this you have touched a bit the eigenvalue and eigenvector already, is it? But just maybe you need a bit refresh how to check how to get the eigenvalue and eigenvector. Okay, we directly proceed to this one. Okay, we directly proceed to the example. Okay, how are we going to get the eigenvalue and eigenvector? I show you how to do, then you might will remember back. Just recap a bit lah, huh? Okay, eigenvalue and eigenvector, of course, got its own function. Okay, we will see several here, but not so much lah. Okay, actually, eigenvalue and eigenvector is very important to represent some properties of the matrix. Okay, but it is too large lah. Okay, for the syllabus, we will just use several. Okay, so before that, we'll have a look at this one. So how we're going to get the eigenvalue and eigenvector? Okay, some of us, they like to use modulus of A minus lambda I. Depends, okay? Some of us, some of other mathematicians, they like to use lambda I minus A equal to 0. Both is the same, okay? Both is the same, we get the lambda, where the lambda is the eigenvalue. Okay, but I prefer to use the first one because the first one no need to change the sign. If you use the second one, every sign you have to change. Okay, so will be sometimes we get mistake there, easily get mistake. But again, if you are get used or familiar with a second one, then go ahead. Okay, up to you. Okay, but here I will use the first one lah. Okay, but basically they are the same lah. So A minus lambda I. So that means your A minus lambda times I. What is the I? I is 1, 1, 1. And then 0, 0, 0, 0, 0, 0. So lambda I means what? Means this one become lambda, lambda, lambda. So A minus lambda I. So 2 minus lambda. Okay. And then this one 2 also minus lambda. This one also 2 minus lambda. The rest, nothing changed because 0 minus 0, so still 0. 1 minus 0, still 1. That's why I prefer to use A minus lambda I. Because if you use lambda I minus A, then it will become negative 1, 1, negative 3, and then this one become negative 1, and so on. Okay, so it will a bit chance for you to get mistake there. Okay, so normally I use a A minus lambda I rather than lambda I minus A. Okay, so this one will become 3 and then 1, 0. Okay, so we make this one equal to 0. So how are we going to get the modulus? Normally we choose any row or any column. Okay, up to you, any row or any column. Okay, maybe I take this row. So I will have 2 minus lambda. Normally we take the row or column with 0. Okay, sorry, I don't take that one. I prefer to take this one. Why I take this one? Because of 0, 0 here. So I don't need to calculate so much. Okay, so plus, minus, plus. So 2 minus lambda times 2 minus lambda, and then 1, and then 1, and then 2 minus lambda equal to 0. So that means it's 2 minus lambda times 2 minus lambda times 2 minus lambda. So I will have 4 minus 4 lambda plus lambda square and then minus 1 equal to 0. So that means I have 2 minus lambda times lambda square minus 4 lambda plus 3 equal to 0. Okay, 3 I think can be easily seen that will be 2 minus lambda and then lambda minus 3 lambda minus 1 by factorization or calculator, up to you. Okay, so that means I have lambda is 2, lambda is 3, and lambda is 1. Okay, any question up to this point? Is everything okay? Okay. Okay, so we continue. So this one is get the eigenvalue. Okay, from every different eigenvalue, you will have a corresponding eigenvector. Okay, so let's see. I take 1 first. Okay, how you're going to get the eigenvector? You plug in. Okay, you plug in the eigenvalue you choose. Let's say 1. Then plug in here, it will become 1, negative 1, 1. And then 0, 1, 0. 1, 3, 1. Okay, times you can put x, y, z. You can put e, 1, 1, e, 1, 2, e, 1, 3. The 1 here represent this is a first eigenvector. Okay, 1, 2, 3 represent the position in the eigenvector. Okay, equal to 0. So that means from here you will get equation. Okay, for the first equation you will get e11 plus e13 equal to 0. Third one you will get same thing, e11 plus e13 equal to 0. Okay, quite normal you get the same equation. Okay, if you get the same equation, then this one no need to care. You want to put or not, up to you, but it will be useless lah. Okay, and then the second one, it will become negative e11 plus e12 plus 3e13 equal to 0. So from the first equation, okay, from the first equation, I get e11 is equal to negative of e13. So you substitute this one into here. We try to get everything in terms of one of it. Maybe e11, maybe e12, maybe e13. Okay, this one seems we make everything in terms of e13. Okay, we try to elaborate e11 in terms of e13, e12 in terms of e13 as well. Okay, so we substitute e11 as negative e13, then I will have e13 plus e12 plus 3e13 equal to 0. So that means e12 is equal to negative 4 e13. So that means what is your e1? Your e1 will be, okay, e11 is negative e13. e12 is negative 4 e13. Okay, and then e13 itself is e13. And then you can choose any number for e13 to make everything become an integer. Okay, so I choose 1, so become negative 1, negative 4, and then 1. It depends on what is your choice. Okay, here I choose 1, then I have negative 1, negative 4, and then 1. If let's say you choose negative 1, then your answer will be 1, 4, negative 1. Can, no problem. It will be still the same. Okay, these two answer is the same. Okay, these two answer both is correct. So this one is E1. So similar thing for E2 and E3. Okay, you try to get the E2 and E3, see whether you get the same answer as in the notes or not. Okay, they get 1, 2, 3 as an eigenvalue. Okay, here they use x1, x2, x3 lah, but normally I use E11, E12, E13, and then later I will use again E22, E21, E22, and E23. Okay, it's depend lah. This one is nothing wrong or correct. You use XYZ also can. You use X1, X2, X3 also can. You use E21, 22, 23 also can. Okay, up to you. So now your turn to try to get the second eigenvector and third eigenvector. See whether it is same as this one is. You see, they choose if they choose the answer for 1, 4, -1. Okay, so now your turn to choose lambda equal to 2. See whether you get 0, 1, 0 or not. See whether you can get it or not. Try it now. Okay, so get the answer for the second one and the third one. Do you need I do it? Hello, do you need I do it? No need, huh? Okay, then I proceed. Okay, there are sometimes, okay, this one is 3 by 3. 3 by 3 still okay, not so difficult for us to proceed to get the equation. Okay, but there are sometimes the matrix is too big, let's say 4 by 4, 5 by 5, and so on. Okay, or sometimes the number of the eigenvalue is not like it's not like this one. It's not the whole number. It can be decimal, it can be fraction, sometimes even can be an imaginary number and so on. Okay, so there are various of kind of situation for our eigenvalue and eigenvector. So sometimes it's difficult for us to get something like this. So that's why, okay, here we have one method we call numerical method. Okay, but numerical method, they have the condition. Okay, they first one is if you are using the power method. If you are using the power method, you only can find the dominant eigenvalue. Okay, what is dominant eigenvalue? For example, okay, for example, I have 1, 3, and -5. So which one will be my dominant eigenvalue? The biggest one, which is -5. We don't care the positive or negative sign because if you want to find the dominant, we will have we will use a modulus. Okay, so positive, negative, we don't care. Okay, so here among these three number, if only we compare the value, the 5 will be the biggest one. So that's why the -5 will be the dominant eigenvalue. Okay, and 7, 6, -4, -5, the eigenvalue, the dominant eigenvalue will be 7. So if you use the power method, what you can find is only the dominant eigenvalue. Okay, of course, we have a lot of method because, as I said, okay, eigenvalue and eigenvector is very important. Okay, it's very important in the explore the properties of the matrix. So that's why we need it a lot. Okay, so we have various of method in order to help us to find. Okay, so now, okay, so now let's see how we're going to use power method. We direct proceed to the example. Then we will easier to understand this one. Okay, so again if we talk about the numerical method, that means we have a lot of iteration. We can have a lot of iteration. Okay, so now let's say I want to use a 6 iteration of the power method. I want to find the dominant eigenvalue. Okay, they don't say also you can't find other lah. You only can find the dominant eigenvalue by using the power method lah. Okay, other method maybe you can find other method. Okay, we have inverse power method. And so on lah. Okay, but if you are using the power method, you only can find the dominant one. Okay, so now how are we going to solve it? So first we have this matrix 17, 9, 5, and so on. Okay, and then by using the power method, sorry, 1 minute. Kalau 3,5 macam tu boleh tak? One more thing, semalam hantar punya itu piala, I lupa nak bawa. Besok I hantar ke you punya asrama ke atau macam mana ke, boleh tak? Yang sekarang I ada mock check dengan piala yang last time punya. Last time hantar sampai rumah I punya. Okay. So okay, so by the power method, okay, this one is a formula. So let's see how we're going to get how we're going to use this formula. Okay, so first, normally they will give you a initial guess. Okay, initial guess y0 is equal to what? Okay, if they doesn't give you, okay, then you use 1, 1, 1, 1, 1. Okay, if 3 by 3, that means 1, 1, 1. Okay, 4 by 4, that means 1, 1, 1, 1. Depend on what is the dimension of the matrix. Okay, so initial vector we take 1, 1, 1. So we put in 1, 1, 1 here times our a. Okay, times our a, that means you will get the new x1. So okay, you put in 1, 1, 1 and then times with your a, then you will get your x. Okay, after you get your x, you take the biggest one. Okay, among these three, which one is the biggest? 31. Okay, so I take out the 31. So everything divide by 31. 31 divided by 31, I get 1. 18 divided by 31, I get 0.5806. Use decimal here. Okay, don't use fraction. Okay, if you use fraction, later you will be crazy. It will be very long. Okay, so negative 13 divided by 31 as well. And then after you have this one, so this one is your new y. So take again your new y times your a, and then you will have a new x. Again, choose the biggest one, 20.1284. So I take out. And then everything divided by 20.1284. So I get the new y. I repeat the procedure. Okay, because they said 6 iterations. So I do until 6 iteration. And then this one will be my dominant eigenvalue. Okay, if you continue, you will see it will be converged lah. Okay, you see 31 to 20. Okay, the difference is about 11. 20 to 15, the difference is about 5. 15 to 13, difference is about 2. 13 to 13, okay, difference is on the decimal. Okay, 13.08 to 12.66, again the difference is only in the decimal. So you can see their difference is getting smaller and smaller. Okay, so while we continue, you will see, okay, the eigenvalue is something near around 12 point something. Okay, we don't know it's what lah. Okay, but around is around 12 point something lah. Okay, so this one will be our eigenvalue. And then this one, the new y, the latest y, will be our correspond eigenvector. Okay, so you can see 12.664 will be your eigenvalue. And then this one, 1, negative 0.397, negative 201. This one will be your correspond eigenvector. Okay, so this is by using the power method in order to find the dominant. Okay, if you want to find the smallest, okay, smallest eigenvalue, just now is the biggest. Now if you want to find the smallest, then we use inverse power method. Okay, basically their idea is the same. Okay, now let's see. Again, I have this equation. Okay, I have this equation, and then I want to use the inverse power method in order to solve in order to get the smallest eigenvalue. Okay, so the formula now will be this one. We compare again. Just now is x is equal to ay, and then y is what? Y is 1 over mr times the xr. Okay, that means it's one. This one take out lah. Everything divided by this number lah. Okay, then you have this one here. Okay, now your yr minus 1 will be axr, and then yr will be 1 over mr xr. Okay, before that, maybe we will try for the power method first rather than inverse power method. Okay, you try the first one. Can I leave it to you? We don't want to do here. Is it okay? Or you need we do it here? First question, just normal way to do. Is it okay if I leave it to you? Okay, can can or not? Can. Okay. So first one, I leave it to you. Okay, now you do the second one by using the power method. Try to do the second question. Okay, done. Get the answer or not? Do you need I do it? Lama, I does not bring my calculator. If by using the calculator, this one actually the power method is not that difficult to do, but I does not bring my calculator now. Okay, I'm not sure need how many iteration, but okay, I show you the answer here. Okay, 1 minute. Okay, so this one is tutorial 5. Tutorial 5, question 2. Okay, so this one, okay, let's say they start with 111. Okay. This one dot one. What's different? Okay, this one they does not write need how many iteration, but you get after the first iteration, what you get? This one is it? Normally we don't do like this, huh? Normally we don't do like this. We do what like similar in the notes here. Okay, we do by using the table here. Normally we follow the table here. Will be easier. Okay. So I don't bring my calculator lah. If by using calculator, this one will be much easier. Let me see. Let me find. If you are using the white one or the silver one, then it will be very easy for you to do this one. Let's not bring it. No mind. Okay, you just follow this one. I'm not sure how many iteration you have. Okay, but depends. Okay, if they does not mention how many iteration to stop, then as long as the difference is less than 0.01, then you can stop already. Difference is difference of the difference of the eigenvalue is less than 0.01, then you may stop. Okay, 0.00 something, then you may stop. You have to make sure O is less than 0.01, then only you can stop. Can or not? Not necessary. I repeat again, not necessary 6 iteration. I also cannot confirm how many iterations. Sometimes 2 or 3 iteration we do already, but most of the times need to like 5 or 6 times. Most of the times lah. Okay. Can or not? Need I do or not? If need, then I do it. No need, confirm you can get, everyone can get. Okay lah, no need that, then I proceed lah. Okay, so again lah, if you need, you just let me know. Okay, so inverse power method. So now let's see how we're going to find the smallest eigenvalue by using the inverse power method. Okay, so what is inverse power method? So basically we use this one. Okay, but we need to find the y first. Okay, we need to find the y. How are we going to find the y? Okay, how are we going to find the y? So let's say, okay, we use the Gauss elimination. Still remember what is Gauss elimination? Anyone still remember what is Gauss elimination? We use Gauss elimination in order to find the unknown. Remember? we have few methods. One is called Gauss elimination. One more is called what? I can't remember already, but also is something we try to get the RRE form. Okay, we will try to get something like this one. Okay, 1 1, and then this one, if possible, you also can get into 1. Then you can get your y1, y2, y3 easily. Hey, remember or not? Why so quiet? Okay, I do it here. Okay, so this one, I show you how to do lah. If you cannot remember lah. 17, 0, -5. This one just a bit refresher, 9, 8, -5. 5, 10, -3. Okay, and then what you want to get? Y1, Y2, Y3. Okay, Y1, Y2, Y3. We try to get our X lah. Okay, actually is the concept is something like this: 17, 0, -5, and then 9, 8, -5, and then 5, 10, -3, and then times with x1, x2, x3 equal to your y1, y2, y3. And then what we want to get, we try to get this one. Okay, we try to get the x1, x2, x3 in terms of y1, y2, y3. Okay, so how are we going to do that? Okay, so we use row operation. We call row operation. Okay, row operation means that, okay, first step, we make the diagonal become 1. We make this one become 1. So the easiest way is 1 over 17, R1. That means I take the first row times the 1 over 17. Then what I have, 1, and then 9 over 17, and then 5 over 17, and then y1 over 17. The rest is still the same, 0, -5, 8, -5, 10, -3, y2, y3. And then next, what you need to do is you have to get this one into 0. Okay, get this one into 0. So how are we going to do that? So we get only can plus lah. So I take the 5R1, 5 times the R1 plus the R3. So 5 times 1 plus the -5, I will get 0. Row 2, I no need to do the operation row 1 to the row 2 because row 2 is already 0. Okay, so row 1, row 2 is still the same, nothing changed, just a row 3 change. Okay, so this one will be 45. Alamak. Doesn't bring up letter. Okay, hopefully this one can do lah. Okay, so 45 over 17, 45 over 17 minus, oh sorry, plus. So sorry, it will be -5, -5. Lama, okay, in terms of this one, -40, -40 over 17. So this one 25 over 17. 25 over 17 minus of 3. So again, the answer will be negative 26 over 17. So here, this one, y1 over 17, y2 still y2, and then this one will become 5y1 over 17 plus y3. Okay, so this one only done the first step. Second step, I want to make this diagonal become 1 as well. So 1 over 8 of R2. 1, 9 over 17, 5 over 17, y1 over 17, then 0, 1, okay, because 8 divided by 8. 10 divided by 8, 5 over 4. And then y2 over 8. Okay, and then this one 0, negative 14 over 17, negative 26 over 17, and then 5y1 over 17 plus y3. So now I want to make this one become 0. How to make this one become 0? Is just take 40 over 17 R2 plus R3. This one should be not the new things for you lah. Huh? Okay, 1, 0, 0, and then 9 over 17, 1, and then 0, 5 over 17, 5 over 4. So this one will be 40 times 5 will be 200 divided by 17 times 4 minus 26 over 17. Okay, so I get the answer of 24 over 17. So this one will be y1 over 17, y2 over 8, and 5y1 over 17 plus y3. Okay, and then this one times the this one times the 40 over 17. So I will have 5y2 over 17. So this is our RE form. Okay, so that's how, okay, they have this one. Is it the same? I think so lah. Yeah, it's the same lah. So this is how they get it here. Okay. So after they get this one, okay, after they get this one, so that means from here, okay, we start from the last one. That means 24 over 17 x3 will equal to this thing. So this one will be your x3. So of course I need to move my 17 over 24 here lah. So this one will be my x3. Okay, and then after you get your x3, you can get your x2. Okay, so this one is if you times inside, if you times inside 5 over 24, 5 over 24, y1 plus 17 over 24. Okay, I make it y2 first. So 5 over 24 y2 plus 17 over 24 y3. So this one will be your x3. How about x2? x2 from here. So this means x2 plus this one times your x3 will be y2 over 8. So that means 5 over 4 of your x3 okay. Let me think. This one times x3 equal to this one. So x2. So this one will become negative, and then plus your y2 over 8. Okay, so you will see something like this. Okay, but if you compare to here, you only have y2 x3. That means they does not make your x3. Okay, they does not make this one into here, because you will get a number first. You will get a number and then you just plug inside, so that you no need to calculate this one. Okay, you can just direct use the x3. Okay, so after that you have the x2, you have the x3, so you put inside, then you will get your y1 as well, x1 as well. Okay, so this is the idea. Okay, so now let's see how we're going to do that. So now I have my xr already. This is my xr. Okay, so this is my xr, and then okay, again I start with 111. Okay, I start with 111. Okay, and then I take my 111. I take my 111 times my A inverse. Okay, so what is your A? This one is your A. By calculator, you can get your A inverse. Okay, you get your A inverse, and then you times the 111, you will get here. Again, you take the biggest number. Okay, you take the biggest number. We don't care the biggest number is positive or negative lah. We just take the value with the value which is the biggest. Okay, so you take the biggest, again everything divide by the biggest number. Again, you take this one times your A inverse, you get the new one. Again, you take the biggest one and then everything divide by the biggest one. Okay, until you found that does not change much. Okay, you see negative 0.3998 and negative 3999, 1 and 1, negative 6.002, negative 0.6001. So the difference is very, very small. It's less than 0.001. Okay, so that means we can stop already. So that means, okay, after that, don't stop here. If power method, you just stop here. You just stop here. Then this one will be your eigenvalue. This one will be your eigenvector. This is power method. If inverse power method, you have to do until this step. That means you have to times the A inverse again. Okay. After you times the A inverse again, okay. So now, okay, let me see. If you just stop here, okay, if you just stop here, your dominant eigenvalue of A inverse is 1 over 1 over your is 0.5. Okay, is that means it's 1 over lambda 3 is 0.5. Okay, and then the correspond will be negative 0.4, 1, and then negative 0.6. So the smallest, okay, the smallest, because this is the biggest for A inverse. Okay, so for A inverse, for smallest, if you take the 1 divided by the biggest number, then you will get the smallest number. So that means your smallest eigenvalue will be 2. Okay, your smallest eigenvalue will be 2, and then your correspond eigenvector does not change. Still negative 0.4, 1, and then negative 0.6. So, oh, sorry, a bit mistake. You can just stop here. Okay, you can just stop here. So that means your smaller number, this one will be your 1 divided by this one. Okay, 1 divided by this one will be your smallest eigenvalue, and then this one will be the correspond eigenvector. Okay, so now Again, by using the inverse power method, try to do number 3. Okay, so now let's see. Okay, how we're going to do this one? Again, because I don't have calculator with me, so maybe I will just do several steps. I don't mind you to use a calculator in order to get the A inverse, okay? But you need to find the, okay, 1, 2, -5, and then 2, 3, 3, and then 2, -2, 8. Okay, y1, y2, y3. Okay, so for this one, since it's already is 1, so I will have -2r1 plus r2, and then 5r1 plus r3. This one, if you can do it quickly, then you can just direct proceed lah. Okay, so I will have 1, 0, 0. So 2, 2, y1. Okay, so -2, -4 plus 3, -1. -4 minus 2, -6. If any mistake, please let me know. 10 plus 3, 13. 10 plus 8, 18. So this one will be -2y1 plus y2, 5y1 plus y3. Okay, and then this one will become -r2 because I need the positive. Okay, and then after that, -r2. Sorry, negative of 13 r2 plus r3. So that means it will become 1, 2, 2, y1, and then 0, 1, 6, 2y1 minus y2. Okay, and then 0, 0, negative, negative. Oh, sorry, this one should be positive. Huh? Okay, and then 13 times 6, 78. 78, -78 plus 18, -60. Again, correct me if you found any mistake there. Okay, so 13 -26, -26 plus 5, -21. Plus 13 R2, 13 Y2, and then plus Y3. Is it the same? So this one will become -1/60 times -21 y1. Anything wrong, please let me know. Plus y3. And then for your y2, x2 will be 2y1 minus y2 minus y2, and then minus 6x3. Okay, your x1 will be y1 minus 2x2 minus 2x3. Is it the same or different? Any questions there up to this point? Same, huh? Okay. Then I proceed lah. Okay, so after you have this one, Okay, so does it mention start with what? Okay, they does not mention where to start. So I take 111 now. Okay, so 111. So that means you have your x. X is a inverse. Okay, according to the formula will be a here lah. Huh? Okay, a inverse y. And then you also have your m. Okay, the biggest eigenvalue, and also you will have your y. Okay, so R lah. So when the first one is 111, and then you take your A inverse. I use matrix calculator here. Again, like if you have white calculator, then will be easier lah. If you are using the black one, then will be a bit trouble for you lah. Because the white one, the display is quite user friendly. Okay, so let's see. 1, 2, -5. Two, 3, 3. 2, -2, 8. 2, -2. So we get the inverse. Okay, inverse, we insert this one as A. Your calculator also have this function lah. Huh? Okay, so we times with 1, 1. Alamak. Okay, 1, 1, 1. So we get the A cross B. Okay, A cross B. Alamak, how to change it to decimal? Huh? Let me close a few tabs because very slow. Okay, so I get 1/6. 1/6. 0.1667. Okay, and then 3/10 is 0.3. And then 7/60. 0.1167. Again, if any mistake, please let me know. So what I see, the biggest one is 0.3. So everything divided by 0.3. Oh, this one, if you are using the calculator, you can directly get this one. You get the answer and then you divide by 0.3, then you can direct get the answer lah. Okay, so this one is B divided by 0.3. Not sure whether it can work or not. Okay, can. So I have 5/9. Why always like that? Huh? Okay, 5 divided by 9. 0.5556. Okay, 1 and then 7 over 18. 0.3889. Okay, so the second step will be again this one. Okay, so that means I take this answer, insert in B. Okay, and then I do again A times B. Five times 5 divided by 108. Four six two or 463. 17 over 60. 2833. 31 over 108. 80. 287. 281 again. Oh, 0.02S7. So again, the biggest will be 0.2833. So that means your answer insert in B and then divide by the biggest one will be 17 over 60. 25 over 153. 0.0988. Negative 31,306. Negative 1013. Okay, so we keep repeat lah. Okay, so this one insert in B. Any mistake, please let me know. Wow. How to change it in decimal? 1251836. Okay, so this one you just keep repeat. Okay, keep repeat until you get the answer. Okay, so I will just direct proceed to get the answer lah. So this one I will insert in B. Okay, so among these three, I think the biggest is what? 93 over 340. 27 something. 28. Yeah, okay. So this one will be 93 divided by 340. Okay, so this one insert in B again. Okay, and then A times B again. I just direct proceed lah. Huh? Okay, so this one, so insert in B again. Okay, so let's see which one is the biggest number. I think now, uh, why doesn't give in decimal? I think now the third one is bigger. Yeah, I think the third one is a bigger. So this one will be uh, negative 8839 divided by 301320. Yes. Okay. So again, this one insert in B. I think this one need a lot of step lah. Huh? Okay. So I have this one. Again, I do the A times B. I have this one. Wow. And then I insert in B again. I think now still the third one is the biggest. Insert in B again. I clean this one first. If not, need so many memory. Okay, and then A close B again. Insert in B again. Wow. Okay. So still the same number. Wow. I think I don't want to continue lah. But basically, this is the idea lah. Okay, I don't know how many steps we need. Okay, I don't know how many steps we need, but at last it will be something. This one to this one, nothing change. Okay, not changing much. Okay, maybe less than 0.001, then you can stop already. Okay, but if in exam doesn't mention how many iteration to do, then as long as you see less than 0.01, then you may stop. Okay. So the answer given here, the answer given here is 3 and then 101. Okay, so that means they get something here, they get 0.3333, something like that. Okay, and then 1 divided by this one, and hence they get 3. Okay, I don't know. Oh, correct, to 2 decimal places only. So that means you only need to do three decimal places. Okay, and then if less than 0.01, then you may stop already. Okay, and then I show you the answer given here lah. But this one they use this one. Okay, what they have here. But they also need many iteration. Okay, they need a lot of iteration in order to get the 101. Okay, so I think this one is because the question got a big problem there. Okay, so any questions before I proceed again? Okay, quiet means no questions. Do you want to have a break or we direct continue? Hello? Are you okay if we direct continue first? Quiet means okay lah. So I continue. Okay, are you there? Why no respond one? Okay lah. So we continue. Okay. So okay. So next one is by using the geo. I don't know how to pronounce lah. Gas growing. Okay, gas growing circle. I don't know how to pronounce lah. Okay, gas growing circle. Gas growing circle. Just now we have power method. We have inverse power method. We have one more is the exact method. Okay, that all when our number is real number. Okay, our eigenvalue, our eigenvector is a real number. But if your eigenvalue and eigenvector not necessarily is a real number, okay, let's say it's imaginary number, then you can use this method. Okay, George, I don't know how to pronounce again lah. Pronounce again. Gas, let's say like less growing circle. Okay, so this one only, this one only. Later, this one actually is talking about the polynomial. Polynomial. So if let's say I have the coefficient, okay, a0, a1 until an, okay, and then all of them are real, then the roots of the following polynomial, okay, the roots of this one, okay, the roots of this one are in complex conjugate pair, okay. So what is that means? For example, this one, I have z cube. Sorry, 1 minute. Wait me a while. Okay, so I have this one, z cube plus z square plus z plus 1. If you have z cube, that means you might have 3 answers for z. Okay, you have z1, z2, z3. Okay, z1, z2, z3. If you have something like this, okay, if you have something like this, then, okay, 2 of it will be conjugate. Conjugate, that means, let's say I have 3 plus 2i. Then the conjugate will be 3 minus 2i lah. The coefficient of the imaginary number will be change the sign. Okay, so for example, this one, okay, then you will have one real number and then one conjugate pair. So one real number, one conjugate pair. Okay, because of 3. If you have Z4, then your answer might be something like in 2 conjugate pair. Okay, so now let's see. The second, let's say your lambda be eigenvalue of the matrix of this one. Let's say your lambda is matrix eigenvalue of this one. And then if your A is real, okay, your A is real, so that means you have a matrix. Your A is real, okay, and then that means all your entry, this one, can be 0, can be positive, can be negative, but it must be a real number, okay? Then the A minus lambda I, a polynomial equation of degree n, has coefficient O being real number, So that means this one is real. Then, okay, normally you have a polynomial equation of degree n, and then they have the coefficient O is a real number. Okay, so conclusion is if your matrix is real, that means your eigenvalue are in conjugate pair. So now let's see what they're talking about. Okay, so for example, this one. For this case, okay, you get your eigenvalue in the, you will see your eigenvalue in the conjugate pair. Okay, you will see your eigenvalue in the conjugate pair. It can be both real number, it can be in conjugate pair. But after you get this one, okay, it's a polynomial degree of n, then, okay, this one, it will be in the conjugate pair. This is talking by this theorem. Okay, so by this one, the Gauss theorem, okay, he said if you have a matrix, this is your matrix. Sorry, give me 1 minute. Okay, continue. Okay, so if you have this one as your matrix, and then all eigenvalue will be in the union of this one. Okay, later you will see lah. You will see an example, and then that means okay, if I have this one, so your circle will be what? Your circle will be, okay, the first one will be z minus 10, and then equal to this one, modulus of this one plus this one, so is equal to 1. So that means this is one circle. The second circle is what? Second circle is z minus the diagonal, z minus 2 equal to -1 become 1, 1 plus 2, so 3. And then this one means that is z minus 3 equal to 2. So that means how you're going to draw this 3 circle? Okay, this means the center. The center is on the 10. So the center is 10, and then this means the radius is 1. So 10 minus 1 is 9. 10 plus 1 is 11. So this means your center is at 2. Okay. Okay, I think it's a smaller, I think it's a bigger one. Okay, so this is 2. And then the radius is 3. So 2 plus 3, 5. 2 minus 3, -1. So the bigger one will be this one. And then this one, okay, this one, z minus 3, so your center is at 3. And then the radius is 2. 3 plus 2, 5. 3 minus 2, 3 minus 2, 1. So this is 1. So this one, okay, is the Gauss-Elimination circle. Or we said Gauss-Elimination this. Okay, all your eigenvalue will be inside this all your eigenvalue will be inside this circle. Okay, the possible answer will be inside this circle. This is mean by Gauss-Elimination circle. You need to know how to draw the circle. Okay, it's very important. Okay, so we continue again. Okay, I'm so sorry. Just now got a phone call. I continue. Okay, so they said if the union of S of the n Ds form a region isolated from the remaining Ds, okay, then exactly S of the n eigenvalue lie within this region. So that means, okay, for example, you have this one, so that means you will have 1, 2, 3. Sorry, 1, 2, 3. So that means you will have these three circles. This one is something isolated. So exactly one inside here. Another two will be here. Okay. So if the matrix is symmetry, okay, is symmetry. So something like this: -1, -1, 0, 0, 2, 2. So it's symmetry, and then all the eigenvalue, okay. If this one is symmetry, then all the eigenvalue will be real. So that means this one will be real. Okay, your eigenvalue of this one will be real and inside this circle. So that means will be some point inside here. We don't know. Okay, so that means for this case, okay, after we get the Gauss-Elimination circle, okay, we can conclude one is inside here, another one is another two is inside here. Okay, and then because this one is symmetry, so all the answer will be real. Okay, so we know that the first one is inside 9 and 11. The second one is inside -1 and 5. We cannot confirm, you cannot set, oh, must be 10 lah, because it's between 9 and 11. No, not necessary. It can be 9.5, 9.3, 10.1, 10.2 as well. Okay, can be, because decimal is still a real number, so can be a decimal. Okay, so this one is another example. Okay, this is another example. So if you want to draw the Gauss-Elimination circle of this one, would be z minus 5 is equal to 2, which is the first one. Z minus 1 equal to 1, which is the second one. Z minus 0, which is z lah. So that means it's z equal to 0.5. So that means the center is at the origin, and then it's 0.5 here. Okay, so since this one is not symmetry, okay, this one is not symmetry, so we cannot conclude it must be real number. Okay, but we can conclude, okay, there is one eigenvalue is here, and then another one eigenvalue is here. Okay,